Hey class, today we're going to work through homework 6.4, and this will be day 2 of that. So the first one that we want to do is, after we solve the equation, we also need to check the solution. So we're going to have to go back and substitute in. When you've got a square root, to undo that, you need to square it. And if you do it to one side, you need to do it to the other. So I'm going to square both sides, and when I do that, this will simplify. That's the whole point of squaring it, is to get rid of the radical. And then I have 5 squared, which is 25. So I'm going to add 2 to both sides, and I get that 3x equals 27. And then I can divide by 3, and I get that x is 9. The last step here, they told you to check your solution. So you want to substitute back into the original equation. 9 is going to go in here for the x. So 3 times 9 minus 2 equals 5. And let's check to make sure that's true. 3 times 9 is 27. 27 minus 2 is 25. So the square root of 25 equals 5. The square root of 25 is just 5. That checks out. Let's move on to number 5. The difference here is that we have this plus 14 and then a negative 3 on the outside. That changes things. We have to deal with that first so that we can isolate this. It's going to be negative 3 square root of 16x, and that equals negative 24. Dividing by negative 3 says 16x equals 8. Now we're back to the start, and we can square both sides. So I'm going to square both sides, and I get 16x equals 64. I'm going to divide by 16, and I get that x is 64 over 16, so 4. Last step, I need to substitute this back in. So negative 3 square root of 16 times 4 plus 14 equals 10, negative 10. 16 times 4 as a square root, you're going to have negative 3 square roots of 64 plus 14 equals negative 10. So let's see if this is true. The square root of 64 is just 8. So this is negative 3 times 8 plus 14 equals negative 10. Negative 3 times 8 is negative 24 plus 14 equals negative 10. This is negative 10, and it equals negative 10. So that checks out. The next problem they ask us to look at is to talk about male Asian elephants and their height. Their height can be measured from the shoulder in centimeters. And the T is age in years. So the first step that I'm going to do is make a variable box. I have the T variable is independent, and the height variable is dependent. So T is age in years, and height in centimeters. They give us an initial measurement of 300 centimeters, and that lets me know that it needs to go in for the h variable on my equation. So we're going to take the 300 and we're going to substitute it in for the height. So this means that 300 equals 62.5 cube roots of t plus 75.8. This matches what we did on number 5. The first thing you're going to do is subtract 75.8 from both sides. So you're going to get 224.2 equals 62.5 cube roots of t. Just like in number 5, the next thing you need to do to isolate this cube root is to divide by 62.5. So you get that the cube root of t is 224.2 divided by 62.5. That equals 3.587. And again, just like number 5, you need to undo what has been done here. So you're going to undo a cube root by cubing everything. And that will cancel out this radical. And then you're just left with t equals 46.160. So now that I know one solution here, I can write it over in my variable box and complete the problem. 46.160. So from here, you can write your sentence. The elephant is 46.160 years old. Let's move on. We're going to tackle 10. And now we have, like on the other side, on number 1, we just have numbers, a constant over here. But now we're going to work with variables on 2 sides. So, when we square both sides in number 10, you get this to cancel, so you have x plus 22, and then you have x plus 2 squared. In other words, we need to expand it out. X plus 2 squared just means that we can use an array to multiply. X plus 2, x plus 2. Multiplying inside, we have x squared plus 2x plus 2x plus 4. So this will be x plus 22 equals x squared plus 4x plus 4. So to actually get the solution, now that we have an x squared in the mix, to get the solution, we're going to have to set this equal to 0. So I'm going to subtract x and 22 from both sides to set it equal to 0. When I do that, x minus x cancels. 22 minus 22 cancels. And I'm left with 0. 0 equals x squared. 4 minus 1 is 3x. And then 22 minus 4 will give you negative 18. To solve, now that it's equal to 0, what I can do is factor. And I can factor 18 into 6 times 3. 6 times 3 is 18. I also need to get these two numbers to add up to 3. So to be able to do that, 6 has to be positive and 3 has to be negative. So we'll check again. 6 minus 3 is positive 3, and 6 times negative 3 is negative 18. So that means that these two numbers are my factors. So x plus 6 times x minus 3 equals 0. Okay? So these factors can turn into roots. You have x plus 6 equals 0 and x minus 3 equals 0. X plus 6 equals 0. Subtract 6 from both sides, and you get x equals negative 6. That's one solution. You also have x minus 3 equals 0. And that's this factor right here. Add 3 to both sides, and you get x equals 3. Just like we did in the last step, in the last problem, you're going to want to substitute these two answers back into the original equation. Okay? So, if you substitute a negative 6 up here, you have negative 6 plus 22, and that is equaling your negative 6 plus 2 over here. So this is the square root of 16, which is 4, and over here we have negative 4. So in my answer space, I have 4 equals negative 4. This is a false statement, and it means that negative 6 is not a real root. It's an extraneous solution. Let's check x equals 3. Again, we have the square root of 3 plus 22 equals 3 plus 2. So off to the side here, I'm just going to substitute back into the original equation the root that I got. So if x equals 3, anywhere I see an x, I'm going to substitute in 3. 22 plus 3 is 25, and 3 plus 2 is 5. You can see that 5, the square root of 25, equals 5. That checks out. So this is a correct solution down here, x equals 3. We can try the same step over here. We can raise everything to the 4th power to get this to cancel, and we get 2 minus 9x squared. Then we have 3x to the 4th power. So 3x times 3x times 3x times 3x. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And x times x is x squared. X squared times x is x cubed. Times x is x to the 4th. From here, I want to get everything isolated so that it equals 0. And I get 0 equals 81x to the 4th plus 9x squared minus 2. And I'm going to take this to my graph. And I'll type in this equation. 81x to the 4th plus 9x squared minus 2. There my quartic comes up, and I can then just grab the zeros straight off the graph. So I have one at positive 1/3 and one at negative 1/3. So these are my two solutions, and now I need to substitute them back in to make sure that they work. Okay. On number 14, we're going to multiply by the reciprocal. So the first thing I can do is divide by 2, and I get x to the 2/3 power equals 18 divided by 2, which is 9. The reciprocal of 2/3 is 3 over 2. So I'm going to raise both sides to the 3 over 2 power. The whole point of raising to the reciprocal is so that that cancels. So you have x. Now we're going to take the square root of 9 and raise it to the 3rd power. And when we do that, it's going to be 3 to the 3rd power, so x equals 27. Let's work on number 16.